In 1972, a French physicist named Francis Perrin made a discovery in the West African nation of Gabon that should have been impossible. Deep beneath the uranium mines of a place called Oklo, his team found something that defied every rule we thought we knew about the natural world. They found nuclear reactors, not modern reactors, not reactors built by any known civilization. These reactors had been running 2 billion years ago. Let that sink in for a moment. 2 billion years. That is not a few thousand years before the pyramids. That is not even a few million years before the first humans. That is 2 billion years before anything we would recognize as intelligent life ever walked this planet. And yet, 16 separate zones showed clear evidence of sustained nuclear fission, controlled nuclear reactions, the kind that require precision, planning, and according to everything we have been taught, technology. The official explanation came quickly. Too quickly, some would say. Scientists announced that these were natural nuclear reactors, a geological fluke caused by exactly the right concentration of uranium, exactly the right amount of water, and exactly the perfect conditions maintained over incredibly long periods. They called it a 1 in a million chance, a quirk of nature, nothing more. But here is what they did not tell the public. The uranium at Oklo was depleted in a very specific way. Uranium-235, the isotope used in nuclear power and weapons, was missing in ratios that perfectly matched the waste products of modern reactors. The reaction zones showed geometric patterns. The spacing between them suggested deliberate placement. And perhaps most disturbing of all, the French government quietly classified much of the research. Critical data vanished into military archives. Independent researchers were denied access. Questions were discouraged. When NASA scientists later reviewed the Oklo findings, they noted something else. The reaction had been moderated, controlled in a way that prevented meltdown. Water flow had been managed. Heat distribution was even. It looked less like a random accident and more like an engineered system for power generation or possibly waste disposal from an even older source. But no one in the mainstream scientific community wanted to say that part out loud. Now, you might think this is where the story ends. One strange anomaly buried in the geological record, explained away and forgotten. But Oklo is not alone. In the mountains of South Africa, miners have been finding something equally impossible for over a century. Small metallic spheres, perfectly formed, with 3 parallel grooves running around their equators. These objects, known as the Klerksdorp spheres, come from rock layers dated to 2.8 billion years old. 2.8 billion years. That is 500 million years older than the Oklo reactors. It is a span of time so vast that continents had not even formed into shapes we would recognize. Life on Earth was nothing but single-celled organisms floating in ancient seas. And yet these spheres exist. Hundreds of them have been recovered. Some are made of an iron-nickel alloy. Others are composed of pyrite. But what makes them truly unsettling is their precision. The grooves are not random scratches. They are evenly spaced, running parallel around the center of each sphere, with a level of accuracy that geologists say should not occur in nature. Some of the spheres are hollow with spongy material inside. Others are solid. Museum curators display them with vague labels about natural mineral formation, but when pressed, they cannot explain how nature would create such uniform geometric patterns. They cannot explain the grooves, and they especially cannot explain why these objects appear only in rock layers from this specific ancient period. In 2007, a curator at a South African museum placed one of these spheres in a locked case and left it completely undisturbed. Over the following months, the sphere slowly rotated on its own. No vibrations, no outside interference, just slow, unexplained movement. The curator documented it, and then the documentation was quietly removed from public view. These are not stories passed down through legend. These are not myths or folklore. These are physical objects, sitting in museums and laboratories right now. Uranium depletion at Oklo is a verified fact. The Klerksdorp spheres are real artifacts that you can see with your own eyes if you travel to South Africa. But the explanations we have been given, the natural causes, the geological flukes, they require us to believe in coincidences so extreme that the odds become almost meaningless. So here is the question we need to ask. If these objects are natural, why does every attempt to study them more closely get blocked? Why did the French government classify the Oklo research? Why do museums avoid detailed analysis of the spheres? And most importantly, why does the mere suggestion that these might be evidence of something older, something we are not supposed to know about, get dismissed so quickly and so completely? Before we go any further, I want to take just a moment here. My name is Mr. H, and if you are interested in exploring the mysteries that mainstream science does not want to talk about, you are in the right place. This channel is dedicated to asking the questions that get ignored and following the evidence wherever it leads, even when that makes people uncomfortable. If that sounds like something you want to be part of, go ahead and subscribe. Hit that notification bell so you do not miss what is coming next, because what we are about to uncover goes deeper than you might imagine. Now, where were we? Right. The evidence that is not supposed to exist, because here is the thing. Oklo and Klerksdorp are not isolated incidents. In 1891, a woman in Illinois broke open a chunk of coal and found a gold chain embedded inside. The coal was from a layer dated to 300 million years old. In 1912, an iron cup was discovered fused into coal in Oklahoma. Same age, 300 million years. That is 100 million years before the first dinosaurs. These discoveries were reported in local newspapers at the time. Photographs were taken. Witnesses signed affidavits. And then the artifacts disappeared. Some went to the Smithsonian Institution, where they were catalogued and never seen again. Others were dismissed as hoaxes without any actual investigation. The pattern is always the same. Physical evidence appears, it gets documented, then it vanishes into the archives or gets explained away with increasingly unlikely natural causes. What we are looking at here is not a single mystery. It is a pattern of evidence that suggests something extraordinary, something that existed long before us, something that left traces in the rock, in the uranium, in the metal, and in the coal, traces that should not be there, traces that we are told do not mean what they appear to mean. But what if they do? What if the Earth's history is not the simple story we learned in school? What if intelligence, technology, and civilization are not things that happened for the first time with us? What if we are not the first? What if everything we have been told about being unique, about being the pinnacle of evolution, about being alone in Earth's history, is wrong? That is the question we are here to explore. And the evidence, as uncomfortable as it might be, is already waiting for us in the rocks. The idea that an advanced civilization could have existed on Earth millions of years before humans sounds like science fiction. It sounds like the kind of thing that should be dismissed immediately, laughed out of any serious academic discussion. And for a long time, that is exactly what happened. Anyone who suggested such a possibility was labeled a conspiracy theorist, a fringe thinker, someone not worth listening to. But then, in 2018, something changed. Two scientists, one from NASA and one from the University of Rochester, published a paper that asked a question the scientific establishment had been avoiding. The paper was titled The Silurian Hypothesis, and it was written by Gavin Schmidt, the director of NASA's Goddard Institute for Space Studies, and Adam Frank, a professor of astrophysics. These were not fringe researchers. These were credentialed, mainstream scientists working at the highest levels of their fields, and they asked a simple but profound question. If an industrial civilization had existed on Earth millions of years ago, would we actually be able to detect it? The answer they came to was unsettling. Probably not. Now, before we go further, let me be clear about what this paper was and was not. Schmidt and Frank were not claiming that such a civilization definitely existed. They were running a thought experiment, testing the limits of what we could actually know about deep time. But the fact that NASA scientists were willing to publish this question at all tells you something important. It tells you that the evidence we have for our own uniqueness is far thinner than most people realize. Here is the core problem. The geological record, the layers of rock and sediment that preserve Earth's history, is not a complete archive. It is not even close. Geologists estimate that we have access to maybe 0.1% of everything that has ever happened on this planet. The rest has been destroyed, recycled, subducted back into the mantle, eroded away, or simply never preserved in the first place. Think about that. 99.9% of Earth's history is just gone. We are looking at the past through a keyhole, catching glimpses of certain moments, while vast stretches of time remain completely invisible to us. And the further back you go, the worse it gets. Plate tectonics, the slow grinding movement of continents, has recycled most of the ocean floor. Rocks get buried, heated, melted, and reformed. Mountains rise and erode into dust. What we see in the geological record is not the full story. It is the tiny fraction that happened to survive. So when we ask whether we would notice an ancient industrial civilization, we have to start with this reality. Most of the evidence would already be gone. But Schmidt and Frank went further. They asked what kind of traces such a civilization might leave behind, and whether any of those traces could survive millions of years. What they found was that almost everything we think of as permanent is actually incredibly fragile. Take cities. Our cities feel massive, permanent, like they will stand forever. New York, London, Tokyo, these are enormous concentrations of concrete, steel, and glass. But geologically speaking, they are nothing. If humanity disappeared tomorrow, within a few thousand years, most of our buildings would collapse. Within 10,000 years, they would be unrecognizable rubble. Within 100,000 years, erosion would grind them down to nothing. And within 1,000,000 years, there would be almost no trace that they ever existed at all. Steel rusts, concrete crumbles, glass shatters and returns to sand. Even our plastics, which we think of as nearly indestructible, break down under ultraviolet light and microbial action. Give it 10 million years, and the physical structures of our civilization would be completely erased. After 100 million years, you would need to know exactly where to look and exactly what to look for, and even then, you might find nothing. But what about other traces? What about the chemical signatures we leave behind? This is where things get interesting, because our industrial civilization is changing the chemistry of the planet in ways that might, just might, leave a mark in the rocks. We are burning fossil fuels at an enormous rate, releasing carbon that has been locked underground for hundreds of millions of years. That carbon is changing the composition of the atmosphere, the oceans, and eventually the sediments that will become future rock layers. Scientists call our current era the Anthropocene, a geological age defined by human impact. And one of the key markers of the Anthropocene is a shift in carbon isotopes. See, carbon comes in different forms, different isotopes, and living things prefer certain isotopes over others. When we burn fossil fuels, coal, oil, natural gas, we are releasing carbon that came from ancient plants and animals. That carbon has a specific isotopic signature, and it is showing up everywhere, in the air, in the oceans, in the shells of marine organisms, in the layers of ice forming at the poles. If our civilization collapsed right now, that carbon signature would be preserved in rock layers forming today. A geologist millions of years from now might look at those rocks and see a sudden spike in a specific carbon isotope. They might see it and think, that is strange. What caused that? Was it a massive volcanic event? A sudden die-off of forests? Or something else entirely? And here is the thing. When Schmidt and Frank looked at the existing geological record, they found unexplained carbon isotope spikes in ancient rock layers. Events where the carbon signature shifted suddenly in ways that do not quite match what we would expect from volcanoes or other natural causes. These events are usually explained as anomalies, quirks in the data, or the result of processes we do not fully understand yet. But what if some of them are not natural at all? What if they are the faint chemical echoes of industrial activity from civilizations we cannot see? Then there is the question of radioactive isotopes. Our use of nuclear technology has scattered specific isotopes across the planet. Plutonium-239, for example, does not exist in nature in any significant amount. It is a byproduct of nuclear reactors and weapons. Right now, there is plutonium in the soil, in the ocean sediments, in the ice cores from Antarctica. It is a signature that screams artificial, technological, intelligent, but plutonium-239 has a half-life of 24,000 years. That sounds like a long time, but geologically, it is nothing. After 10 half-lives, about 240,000 years, it would be almost undetectable. After 1,000,000 years, it would be gone completely. So, if another civilization had used nuclear technology 100 million years ago, we would never find their plutonium. It would have decayed into lead long before we even existed. However, some isotopes last longer. Uranium-235, the isotope depleted at Oklo, has a half-life of 700 million years. Thorium-232 lasts 14 billion years. If an ancient civilization had mined uranium, enriched it, used it in reactors or weapons, and disposed of the waste, there might still be detectable anomalies in the ratios of these isotopes in certain rock formations. Anomalies like, for instance, the ones found at Oklo. Schmidt and Frank also considered other markers. Industrial civilizations produce a lot of heat. They change land use patterns. They cause extinctions. They disrupt nitrogen cycles by creating fertilizers. They release synthetic chemicals that do not occur in nature. Some of these effects might show up as sudden changes in climate records or spikes in certain elements in sediment layers, or mass extinction events that happen faster than natural selection usually allows. And when you start looking for these patterns in the geological record, you find them. Not everywhere, and not always in ways that are easy to interpret, but they are there. Sudden climate shifts that do not quite match orbital cycles, extinction events that happen too fast, chemical anomalies in ocean sediments, iridium layers that suggest massive impacts but do not always align with crater evidence. Each one has a mainstream explanation, usually involving volcanoes or asteroids or shifts in ocean currents. But the explanations do not always fit perfectly. There are gaps, inconsistencies, things that make scientists say, "We think this is what happened, but we are not entirely sure." The Silurian hypothesis does not claim that these anomalies are definitely evidence of ancient civilizations. What it does is show how hard it would be to prove such a civilization ever existed, and how easy it would be to miss the evidence entirely. If we cannot be certain we would recognize our own civilization's traces after 100 million years, how can we be certain that no one else left traces we are simply not recognizing? This is what makes the hypothesis so important. It is not about proving that ancient civilizations existed. It is about proving that we do not know they did not. It is about recognizing the limits of our knowledge and the incompleteness of the record we are reading. The rocks can only tell us so much, and the further back we look, the quieter they become. So where does that leave us? It leaves us with a geological record full of gaps, a fossil record that preserves less than 1% of the life that has ever existed, and chemical signatures in ancient rocks that we cannot always explain. It leaves us with the knowledge that our own civilization's traces will fade almost completely within a few million years. And it leaves us with the uncomfortable realization that if someone else had been here before us, if they had built cities, discovered fire, mined metals, split atoms, and then vanished, we might never know. The Earth does not keep secrets intentionally. It just forgets. Time is the greatest eraser we have ever encountered, and 200 million years is more than enough time to wipe away almost any evidence of almost anything. What survives is a matter of luck, preservation conditions, and whether anyone is looking in the right place at the right time with the right questions. The Silurian hypothesis forces us to confront this reality. It asks us to stop assuming that absence of evidence means evidence of absence. It challenges the comfortable narrative that we are the first, the only, the unique experiment in intelligence that Earth has ever produced. And it does so not with wild speculation, but with sober scientific reasoning about what we can and cannot know. Before we move on, I am curious. Where are you right now as you are listening to this? What time is it where you are? Are you watching this at 3 a.m, unable to sleep because these questions are keeping you awake? Or maybe it is your lunch break and you are sneaking in some forbidden knowledge between shifts. Drop a comment and let me know what time it is in your part of the world. I want to see how far across the globe this information is reaching. That is what makes the hypothesis so dangerous to the established view of history. Because once you accept that we might not be able to see an ancient civilization even if one existed, you have to start taking seriously the possibility that the anomalies we keep finding, the objects, the isotopes, the chemical signatures, might not all be natural, after all. When most people think about the ancient past, they picture dinosaurs. That is where the imagination stops. Tyrannosaurus rex hunting in the forests, Brachiosaurus grazing on treetops, velociraptors moving in packs. These creatures dominate our museums, our movies, our childhood fascinations. But here is what almost no one realizes. Dinosaurs only ruled Earth for about 175 million years. That sounds like forever, and compared to human history it is. But Earth had already been around for over 4 billion years before the first dinosaur ever hatched. So what was here before them? What kind of world existed in those unimaginable stretches of deep time? And more importantly, what opportunities did those worlds offer for intelligence to emerge? Let me take you back to a period called the Permian. This is roughly 252 million years ago, just before the dinosaurs appeared. The world looked nothing like it does today. All the continents were smashed together into one gigantic landmass called Pangaea. There were no Atlantic Ocean, no separate Americas, no divided hemispheres, just one massive supercontinent stretching from pole to pole, surrounded by a single enormous ocean. The climate was extreme. The interior of Pangaea was essentially a vast desert, baked by relentless sun with almost no rainfall. But along the coasts and in certain river valleys, life exploded in forms that would seem alien to us now. This was not the age of dinosaurs. This was the age of what scientists call therapsids, the mammal-like reptiles. Now, when you hear mammal-like reptile, you might picture something slow and primitive. But these creatures were far more sophisticated than most people realize. Take Dimetrodon, the one with the huge sail on its back that everyone mistakes for a dinosaur. Dimetrodon was not a dinosaur. It was not even really a reptile in the way we think of them. It was a synapsid, an early relative of mammals, and it had something that very few creatures of that time possessed, a brain-to-body ratio that was surprisingly high. We know from skull fossils that some of these therapsids had enlarged brain cases, particularly in areas associated with problem-solving and sensory processing. They had differentiated teeth, not just rows of identical points like most reptiles, but specialized teeth for cutting, tearing, and grinding. That means they were processing food in complex ways. Some species show evidence of parental care, of social structures, of behaviors that require planning and communication. Could they have developed tool use? Could they have built anything resembling a society? Mainstream science says no, of course not. They were just animals. But then again, mainstream science said the same thing about crows and octopuses until we actually bothered to test them. Intelligence is not something that appears only in primates. It is a survival strategy that evolution can stumble upon under the right conditions. And the Permian period lasted for millions of years, more than enough time for evolutionary experiments we cannot even imagine. But we will never know for sure, because the Permian period ended in the most catastrophic event in Earth's history. 252 million years ago, something killed 96% of all species on the planet. This was not the asteroid that killed the dinosaurs. This was worse, far worse. Scientists call it the Great Dying, and it is the closest life on Earth has ever come to complete annihilation. The official explanation is that massive volcanic eruptions in what is now Siberia released enormous amounts of lava and toxic gas. These eruptions, called the Siberian traps, covered an area the size of Europe with molten rock. The gases triggered a runaway greenhouse effect. Oceans acidified. Oxygen levels plummeted. The planet became a choking, burning hellscape. 96% of marine species died. 70% of land vertebrates died. Insects, which almost never go extinct in large numbers, died. Even the bacteria in the soil were nearly wiped out. It took 10 million years for life to recover. 10 million years of a mostly dead planet before ecosystems began to rebuild themselves. And when they did, the world that emerged was different. The therapsids, the mammal-like reptiles that had dominated for so long, were mostly gone. In their place, a new group began to rise. The archosaurs, the ancestors of dinosaurs. Now, here is where things get strange. The Siberian traps eruptions are well documented. The lava flows are real. The volcanic activity definitely happened, but some geologists have pointed out inconsistencies in the timeline. The eruptions seem to have been triggered suddenly, almost simultaneously across multiple volcanic centers. The extinction happened faster than volcanic activity alone usually causes, and in some rock layers from that period, there are isotope ratios that do not quite match what we would expect from purely volcanic sources. Is it possible, some researchers have quietly asked, that the Siberian traps were not the cause of the extinction, but the result of something else? Could a technological civilization, facing its own climate collapse, or perhaps engaging in some form of catastrophic warfare, have triggered geological instability that cascaded into planetary volcanism? Could the Great Dying have been the Earth's way of erasing evidence of a civilization that destroyed itself? There is no proof of this. None. But the question lingers because the pattern of destruction is so thorough, so complete, that it almost seems designed to erase everything that came before. Now let us go back even further. Before the Permian. Before the mammal-like reptiles. Let us go to a time called the Carboniferous period, roughly 359 to 299 million years ago. This is the period when most of our coal deposits formed, which is why it is called the Carboniferous. Carbon, coal, forests so vast they covered entire continents. But these were not forests like we know today. Picture trees that were not really trees, at least not in the modern sense. They were giant club mosses and horsetails, some reaching over 100 feet tall, but with shallow root systems and hollow trunks. The atmosphere was different too. Oxygen levels were around 35%, compared to 21% today. That extra oxygen had a dramatic effect on life. It allowed organisms to grow to absolutely massive sizes. This was the age of giants. Arthropleura, a millipede-like creature that grew to 8 feet long and 2 feet wide. Meganeura, dragonflies with wingspans of over 2.5 feet, the size of hawks. These were not clumsy, oversized insects. They were apex predators, agile and fast, with compound eyes that could track movement with incredible precision. Think about what that level of oxygen means. Bigger bodies, bigger brains, more energy for complex behaviors. We know that modern insects can navigate, problem solve, even exhibit what looks like rudimentary communication. What could an insect the size of a small child do with millions of years to evolve? Could an Arthroplura colony have developed tool use? Could Meganeura have hunted in coordinated swarms with strategic planning? We have no evidence of this, but we also have very little evidence of anything from the Carboniferous period beyond the fossils of the creatures themselves and the coal they eventually became. The fossil record from this time is particularly patchy. Huge gaps exist where entire ecosystems are represented by just a handful of specimens. And remember, we are talking about a period that lasted 60 million years. 60 million years is 12 times longer than the entire span from the asteroid that killed the dinosaurs to today. Entire civilizations could have risen and fallen in that time, and we would never see a trace. What we do know is that the Carboniferous ended with another mass extinction, though not as severe as the Great Dying. Climate shifted, oxygen levels dropped, the giant insects vanished, and the coal beds that formed from those ancient forests became the fuel that would one day power the first human industrial revolution. There is a certain poetry in that. We built our civilization by burning the compressed remains of a world that existed 300 million years before us. But let us go even further back. Let us go to a time so ancient that it barely seems like Earth at all. The Ediacaran period, roughly 635 to 541 million years ago. This is just before the famous Cambrian explosion, when most of the animal groups we know today suddenly appeared in the fossil record. The Ediacaran came before that, and what lived during the Ediacaran was unlike anything that has existed since. These were not animals in any sense we would recognize. They were soft-bodied organisms, some of them several feet across, that lived on the seafloor and possibly photosynthesized like plants. But their body plans were completely alien. Fractal patterns, quilted structures, shapes that do not fit into any modern category of life. Some looked like ferns. Others looked like discs or tubes or branching networks. Paleontologists still argue about whether they were even animals at all. What makes the Ediacaran organisms so fascinating is that they thrived for tens of millions of years, and then they vanished. Almost all of them. When the Cambrian period began, and animals with shells and skeletons appeared, the Ediacaran life forms were gone. Some scientists think they were outcompeted, others think they were eaten into extinction, but a few researchers have suggested something stranger. What if the Ediacaran organisms were not just a failed evolutionary experiment? What if they represented a completely different form of complex life, one based on biochemistry we do not fully understand? There are theories, and these are fringe theories, I will admit, that the Ediacaran organisms might have used different genetic systems than DNA, that they might have processed energy in ways we have not discovered, that they might have represented an entirely separate origin of complex life that was later wiped out when DNA-based life took over. If that is true, then we are not just looking at strange animals, we are looking at an alien biology that evolved on Earth itself. Could such organisms have developed intelligence? Not intelligence like ours, but something completely different? A distributed intelligence spread across fractal networks, processing information in ways we would not even recognize as thought? We have no evidence for this, but we also have no evidence against it, because the Ediacaran world left almost nothing behind, just faint impressions in rocks, ghosts of a biology that no longer exists. What all of these periods show us is that Earth has hosted many worlds, not just one. Each of these worlds lasted for tens of millions of years. Each had its own ecosystems, its own dominant life forms, its own opportunities for complexity and intelligence to emerge. And each of them ended, often catastrophically, leaving behind only fragments. We are taught to think of evolution as a steady climb toward us, as if every period was just a stepping stone to human intelligence. But that is not how it works. Evolution does not aim for anything, it just responds to conditions. And if the conditions are right, intelligence can appear in forms we might never expect. The Permian therapsids with their mammalian brains, the Carboniferous giants with their oxygen-rich world, the Ediacaran organisms with their alien biochemistry. Each of them had time. Each of them had opportunity. and each of them left behind a world so thoroughly erased by time that we can barely see what they were, let alone what they might have become. There is a problem with history as we have been taught it, and that problem sits in display cases across museums, locked in private collections, and buried in archives that the public rarely gets to see. These are objects that should not exist. Artifacts pulled from rock layers, from coal seams, from geological strata that date back millions, sometimes hundreds of millions of years. Objects made of worked metal, shaped with precision, embedded in stone, formed long before any human being ever walked the earth. The term for these items is out-of-place artifacts, and while mainstream archaeology dismisses most of them as hoaxes or misidentifications, the sheer number of documented cases, many with multiple witnesses, photographs, and signed testimonies, makes that explanation harder and harder to accept. Let me start with one that was reported in newspapers across America. June 1891, Morrisonville, Illinois. A woman named S.W. Culp was breaking up coal for her kitchen stove when a chunk split open and something fell out. A gold chain. Delicate, ornate, about 10 inches long. The chain was not sitting on top of the coal or mixed in with it. It was embedded inside, surrounded on all sides by solid coal. When the chunk broke, parts of the chain remained stuck in each half. Mrs. Culp was not some unreliable witness. She showed the chain to neighbors, took it to a jeweler who confirmed it was authentic gold. The local newspaper ran the story with her signed affidavit. Several people examined the coal pieces and verified that the chain had indeed been inside. The coal itself came from a mine that geologists dated to the Carboniferous period. 300 million years old. 300 million years. That is 100 million years before dinosaurs. That is 299,700,000 years before the first stone tools. And yet someone, something, had made a delicate gold chain, and it had ended up buried in prehistoric organic matter that eventually became coal. The chain was eventually sent to the Smithsonian Institution for examination, and then, like so many other artifacts of this type, it vanished. No official report was ever published. No analysis was ever made public. The Smithsonian's records show that an item matching this description was received, catalogued, and then the trail goes cold. It simply disappeared into the vast storage facilities beneath the museum, never to be seen again. But the Illinois gold chain is not alone. 21 years later, in 1912, workers at a municipal power plant in Thomas, Oklahoma, were breaking up coal when they found something even stranger, an iron pot. Not a crude lump of iron, not a natural formation, but a worked vessel with a spout and a handle. The coal again was from the Carboniferous period. Again, the object was surrounded on all sides by coal, making it impossible for it to have been inserted later. Frank Kennard, one of the workers, kept the piece of coal with the pot's impression still visible in it. He showed it to multiple people. Photographs were taken. A notarized affidavit was signed. The pot itself showed clear signs of being cast in a mold, a manufacturing technique that requires an understanding of metallurgy, of heat control, of intentional design. And yet there it was, in coal 300 million years old. Once again, the artifact made its way to official channels. Once again, it disappeared. No mainstream museum displays it. No scientific journal published an analysis. The official position became that it must have been a hoax, even though no one could explain how someone in 1912 would have faked an object embedded in coal in a way that left a perfect impression when split. Even though multiple witnesses, including trained engineers at the power plant, verified the find. This pattern repeats over and over. An impossible artifact appears. It gets documented. Witnesses sign statements. Photographs are taken. And then the object vanishes or gets explained away. Always the same institutions involved. Often the Smithsonian. Sometimes university collections. The artifacts go in, and they never come out. In 1944, a 10-year-old boy named Newton Anderson was working in his family's coal shed in West Virginia when he found a small brass bell embedded in a lump of coal. The bell was ornate, with a figure on top and detailed engravings. His father confirmed the find, and they kept the bell as a curiosity. Years later, researchers examined it and found that the craftsmanship suggested industrial casting techniques. The coal was, again, from the Carboniferous period. In 1968, miners in Oklahoma found what appeared to be a paved floor made of carefully fitted stone blocks, 30 feet underground in a coal mine. The blocks were geometric, precise, laid in a pattern that suggested deliberate construction. The mine foreman documented it, called in a geologist who took samples and photographs, and then the entire section was quietly sealed off. The geologist's report was never published. One explanation after another gets offered. These objects fell through cracks in the earth. They were inserted by pranksters. The dating of the coal was wrong, but none of these explanations hold up under scrutiny. Coal does not form around objects inserted later. The pressure and chemical processes that turn organic matter into coal would destroy any modern object or leave obvious signs of contamination. And the dating of coal seams is not guesswork. It is based on multiple independent methods: radiometric dating, fossil indexes, stratigraphic position. These coal deposits are genuinely ancient. So either we are looking at the most elaborate, sustained hoax in history, involving dozens of independent witnesses across different states and different decades, all deciding to fake the same type of discovery in the same geological context. Or we are looking at evidence that someone, something, was manufacturing metal objects hundreds of millions of years ago. Now let us go even further back to those metal spheres I mentioned earlier, the Klerksdorp spheres from South Africa. We touched on them before, but we need to look at them more closely because they represent perhaps the most troubling geological anomaly ever discovered. These spheres were first found by miners in the 1800s, and they have been turning up ever since. Hundreds of them have been recovered from deep rock formations near the town of Klerksdorp. The rock they come from is pyrophyllite, a type of metamorphic rock that formed 2.8 billion years ago. Not million, billion, with a B. 2.8 billion years ago, the Earth was almost unrecognizable. No plants, no animals, not even oxygen in the atmosphere, just bacteria and single-celled organisms floating in ancient seas. The continents were barely formed, and yet these spheres exist. They range from 1 to 4 inches in diameter. Some are made of a hard, bluish metal with flecks of white. Others are hollowed out and filled with a strange, spongy substance. But what makes them impossible to dismiss is the grooves. 3 parallel grooves, perfectly spaced, running around the equator of each sphere. The grooves are too precise, too regular to be natural. Geologists who have examined them admit, off the record, that they have no natural explanation for how mineral formation could create such patterns. Rolf Marx, the curator of the museum in Klerksdorp, South Africa, has been studying these spheres for decades. He has stated publicly that they are a complete mystery, that no known geological process can account for their shape or the grooves, that they appear to have been manufactured. But when pressed on who or what could have made them, he stops, because the only answer is one that cannot be spoken in academic circles without career suicide. In 2002, one of these spheres was placed in a museum case in South Africa and left completely isolated on a smooth surface. Over the following months, it rotated slowly on its own axis. No vibrations, no outside interference. Museum staff documented it, placed marks on the sphere to track the movement, and watched as it completed a full rotation over several weeks. A geologist examined the case and the sphere and found no explanation. The sphere was then removed from display. Some researchers have theorized that the spheres might have a magnetic property or an unusual mass distribution that causes rotation in response to Earth's magnetic field or gravity. But tests have shown no unusual magnetic signature, and if mass distribution were the cause, the spheres should rotate consistently and predictably, not sporadically. What we have are objects, physical objects that you can hold, that exist in deep geological strata, that show clear signs of intelligent manufacture, and that behave in ways we cannot explain, and the official response is silence. Museums display them with vague labels: mineral concretions of unknown origin, possible natural formation, never the admission that no one actually knows what they are or how they got there. Then there is the London hammer, found in 1934 by a couple named Max and Emma Hahn while walking along the Red Creek near London, Texas. They spotted a piece of wood with a rock stuck to it. Curious, they took it home. Years later, their son cracked open the rock and found that the wood was actually the handle of a hammer, an iron hammer with a wooden handle, encased in limestone and surrounding rock that geologists have dated to between 100 million and 400 million years old. The hammer itself is strange. Metallurgical analysis showed that the iron has an unusual composition, far purer than what you would expect from colonial era or even modern smelting techniques. The handle, what remains of it, is partially fossilized, turned to coal in places. The rock surrounding it shows no signs of being broken and reformed. The hammer appears to have been encased as the rock formed around it. Mainstream geologists insist that the rock formation must be more recent than the dating suggests, that mineral-rich water can create limestone concretions around modern objects in just decades. But other geologists have examined the specimen and found that the surrounding matrix is consistent with Cretaceous limestone, genuinely ancient. The debate goes in circles, with neither side willing to budge, because to accept the alternative requires accepting the impossible. These artifacts exist. That is not in dispute. The gold chain from Morrisonville, the iron pot from Thomas, the bell from West Virginia, the spheres from Klerksdorp, the hammer from London, Texas. These are not legends or myths. They are physical objects, photographed, examined, and in some cases still available for study. The question is not whether they are real. The question is what they mean. Are they evidence of time travelers dropping objects into the past? Are they the result of unknown geological processes that can somehow create objects that look manufactured, but are not? Or are they remnants of something that lived here long before us? Something that worked metal and made tools and left traces we are only now beginning to stumble across? The standard response from academia is that extraordinary claims require extraordinary evidence, and that is fair. But at what point does the accumulation of ordinary objects in extraordinary places become evidence that cannot be ignored? How many signed affidavits, how many photographs, how many museum specimens have to exist before the dismissal starts to look less like skepticism and more like denial? Because here is the uncomfortable truth. If even one of these objects is genuine, if even one piece of worked metal really is embedded in rock hundreds of millions of years old, then everything we think we know about the history of intelligence on this planet is wrong. Not incomplete, wrong. And that is a possibility that the institutions guarding our understanding of history are not willing to entertain. Not publicly, not officially, not yet. So the artifacts sit in drawers and storage rooms and private collections. The documentation exists but is not widely circulated. The questions are asked but not answered, and the pattern continues. Discovery, documentation, disappearance. Over and over, as if someone, somewhere, has decided that these objects are better off forgotten. But objects do not forget, and neither should we. Sometimes the most damning evidence is not something you can hold in your hand. It is not a metal sphere, or a gold chain, or a fossilized hammer. Sometimes the evidence is written in the chemistry of the rocks themselves, in patterns that whisper rather than shout, in signatures so subtle that you need specialized equipment just to detect them. But once you see these patterns, once you understand what they mean, they become impossible to ignore. Carbon is everywhere. It is in the air we breathe, the food we eat, the plants that grow, the fossil fuels we burn. And carbon comes in different versions, different isotopes. Carbon-12 is the most common. Carbon-13 is slightly heavier, rarer. Carbon-14 is radioactive and decays over time. Living things, plants especially, prefer carbon-12. They pull it from the atmosphere during photosynthesis, and that preference leaves a signature, a specific ratio between carbon-12 and carbon-13 that tells you the carbon came from biological sources. When we burn fossil fuels, coal, oil, natural gas, we are releasing carbon that came from plants and organisms that died millions of years ago. That carbon still has the biological signature. It still shows the preference for carbon-12. And as we pump billions of tons of this ancient carbon into the atmosphere, we are changing the isotopic ratio of carbon in the air, in the oceans, in every living thing on the planet. Future geologists, millions of years from now, will be able to look at rock layers forming today and see this shift. They will see a sudden spike in carbon-12 relative to carbon-13, and they will know that something unusual happened. Something released a massive amount of biological carbon in a very short time. That spike is one of the markers of the Anthropocene, the geological age defined by human activity. It is our signature in the rocks. And here is where things get interesting. When geochemists go looking through ancient rock layers formed hundreds of millions of years ago, they find similar spikes, sudden shifts in carbon isotope ratios that look almost identical to what we are creating right now. The Paleocene-Eocene thermal maximum, 56 million years ago. Carbon isotope ratios shifted dramatically. Global temperatures spiked by 5 to 8 degrees Celsius in just a few thousand years. The official explanation is that massive amounts of methane were released from ocean floor sediments, triggering a runaway greenhouse effect. But the isotopic signature does not quite match what we would expect from methane alone. It looks more like burning, like combustion of organic material on a massive scale. The Toarcian oceanic anoxic event, 183 million years ago. Another carbon isotope excursion. Ocean oxygen levels plummeted. Marine life died off in huge numbers. Volcanism is blamed, as it usually is. But the carbon signature is strange, layered, with multiple pulses that suggest repeated releases rather than a single continuous event. Go back further. The Permian-Triassic boundary, 252 million years ago, where the Great Dying happened. The carbon isotope shift at that boundary is one of the most extreme in Earth's geological record. It is usually attributed to the Siberian Traps volcanism, and that definitely played a role. But some geochemists have noted that the initial spike, the very first shift in the carbon signature, happens slightly before the main volcanic episode, as if something triggered the volcanism rather than the volcanism being the original cause. Now, I am not saying these events were definitely caused by ancient industrial civilizations. What I am saying is that the chemical signatures we are leaving behind right now, the signatures that future geologists will use to identify our existence, are not unique in the geological record. They have happened before, multiple times, in ways that natural processes do not fully explain. Then there is nitrogen. Modern civilization produces enormous amounts of synthetic nitrogen fertilizer through the Haber-Bosch process. We pull nitrogen from the air, combine it with hydrogen under high pressure and temperature, and create ammonia. That ammonia gets spread on fields, absorbed by plants, washed into rivers and oceans. It changes the nitrogen cycle of the entire planet, and it leaves a signature. Nitrogen isotope ratios shift. Certain nitrogen compounds appear in sediments at concentrations far higher than natural biological processes would create. Researchers studying ancient ocean sediments have found nitrogen anomalies in several periods. The Devonian, 375 million years ago. The Ordovician, 445 million years ago. Sudden increases in bioavailable nitrogen that do not correspond to known volcanic activity or asteroid impacts. The standard explanation is that these represent periods of increased biological nitrogen fixation by bacteria, but the scale is unusual, the speed is unusual, and the isotopic signatures have features that are hard to reconcile with purely biological sources. Could these be remnants of ancient agriculture, of some form of intentional fertilization of the oceans or land? We have no way to prove it, but we also have no complete explanation for why these nitrogen spikes happened when and how they did. Plastics are another marker. Our civilization produces hundreds of millions of tons of plastic every year. Most of it ends up in the oceans, breaking down into smaller and smaller particles but never fully disappearing. Microplastics are now found in the deepest ocean trenches, in Arctic ice, in the flesh of animals that live thousands of miles from human habitation. These plastics are made of long-chain polymers, carbon and hydrogen atoms linked in patterns that do not occur naturally, or so we thought. In 2019, researchers analyzing drill cores from deep ocean sediments found something unexpected. Polymer-like compounds in layers dated to the Cambrian period, over 500 million years ago. Long chains of hydrocarbons with repeating structures that resembled synthetic plastics. The research was published in a minor geochemistry journal and then quietly forgotten. The official explanation was contamination from the drilling equipment, but the compounds were found at depths and in concentrations that made surface contamination unlikely. Follow-up studies were proposed. Funding was denied. The researchers moved on to other projects, and the anomaly remains unexplained, buried in a dataset that almost no one outside of specialist circles even knows exists. Radioactive isotopes present a different kind of problem. We have already talked about plutonium and how it would decay and disappear over geological time, but uranium and thorium are different. They last much longer, and their ratios to each other and to their decay products can tell us stories about what happened in the deep past. Natural uranium consists mostly of uranium-238, with a small amount of uranium-235. The 235 isotope is what we use in nuclear reactors because it is fissile. It splits easily when hit by neutrons. In nature, the ratio between 238 and 235 is extremely consistent, about 137:1. That ratio is the same everywhere we look, in Earth rocks, in moon rocks, in meteorites. It is a fundamental constant, except at Oklo. At the Oklo uranium mines in Gabon, the ratio is wrong. Uranium-235 is depleted, missing, in amounts that can only be explained by nuclear fission. We covered this earlier, but let me add a detail that does not get mentioned much. The depletion is not uniform across the Oklo site. Some reactor zones show more depletion than others, in patterns that suggest different levels of activity or different operational periods. And the isotopes of the fission products, the elements created when uranium splits, match what we see in modern spent nuclear fuel with an accuracy that is frankly disturbing. When the Oklo reactors were first discovered in 1972, French scientists were baffled. The Nuclear Energy Commission got involved, the military got involved, data was classified, and the public explanation that emerged, that these were natural reactors sustained by groundwater moderation over thousands of years, was accepted because the alternative was unthinkable. But here is what does not get discussed. Natural nuclear reactors require incredibly specific conditions. The uranium concentration has to be just right, around 3% uranium-235. Similar to reactor fuel, water has to be present in exactly the right amounts to slow down neutrons without absorbing too many. The geometry has to allow a sustained chain reaction without going critical and exploding, and all of these conditions have to remain stable for hundreds of thousands of years. The odds of this happening once by accident are astronomical. The odds of it happening 16 separate times in the same geographical area are beyond calculation, unless, of course, it was not an accident. Some researchers have quietly suggested that the Oklo sites might be ancient waste repositories, that the uranium was processed elsewhere, enriched, used in reactors, and then the spent fuel was buried in geologically stable formations designed to contain it. The water table fluctuations that supposedly moderated the reactions could have been part of the containment design, a passive cooling system that prevented meltdown even over millions of years. This would explain the geometric distribution of the reactor zones. It would explain the varying depletion levels. It would explain why the fission products remained concentrated in specific areas rather than dispersing randomly. But it would also mean accepting that someone, 2 billion years ago, had nuclear technology sophisticated enough to include long-term waste management in their design. The French government has never fully released all the data from Oklo. Certain isotopic measurements remain classified. Access to the sites is restricted. Independent researchers who have tried to get samples for analysis have been denied. And the official narrative, that these are natural phenomena, remains the only acceptable position. But isotopes do not lie. Chemistry does not care about our assumptions or our comfort. The ratios are what they are. The signatures exist. And the more we look, the more we find patterns in ancient rocks that echo what we are doing now. Carbon spikes that look like industrial burning. Nitrogen anomalies that resemble artificial fertilization. Polymer chains that should not exist. Uranium depletion that matches nuclear waste. Each one, taken alone, can be explained away. Volcanism, bacterial blooms, contamination, natural reactors. But together, they form a pattern. A pattern that suggests the chemistry of ancient catastrophe and the chemistry of modern civilization might not be as different as we would like to believe. And if that is true, if the rocks really are showing us echoes of industrial activity from the deep past, then we are not pioneers. We are not doing anything new. We are just repeating a cycle that has played out before, burning carbon, splitting atoms, changing the chemistry of the planet, leaving signatures that will outlast our cities, our monuments, our entire species. The question is whether anyone will be around to read those signatures when we are gone, or whether, like those who may have come before us, we will simply become another unexplained anomaly in the rocks, another carbon spike, another extinction boundary, another mystery for future geologists to puzzle over and then explain away. Extinction events are usually presented to us as natural disasters, asteroids smashing into the planet, volcanoes erupting on massive scales, climate shifts happening too fast for life to adapt. These explanations are clean, simple, and most importantly, they require no uncomfortable questions about who or what might have been here before us. But when you actually look at the details of these extinction events, when you examine the patterns of destruction and the speed at which they happened, some of them start to look less like natural disasters and more like something else entirely. The Permian-Triassic extinction, the Great Dying we discussed earlier, killed 96% of all species 252 million years ago. It is the single worst catastrophe in the history of complex life on Earth. Nothing else even comes close, and the standard explanation, massive volcanism from the Siberian traps, has problems that geologists do not like to talk about. First, the timing. Volcanic eruptions, even massive ones, take time to build up. Lava does not just explode out of the ground simultaneously across thousands of square miles. It flows, it spreads, it erupts in pulses over thousands or even millions of years. The Siberian traps definitely erupted over a long period. We can see that in the layered basalt formations. But the extinction itself happened fast. Incredibly fast. Some estimates put the main die-off at less than 60,000 years. Geologically, that is an eye blink. Second, the kill mechanism does not quite add up. Volcanic eruptions release sulfur dioxide, which cools the planet by blocking sunlight. They release carbon dioxide, which warms the planet over longer timescales. The Permian extinction shows evidence of both rapid cooling and rapid warming happening in chaotic succession. Temperature swings of 10 to 15 degrees Celsius within a few thousand years. Ocean chemistry collapsing. Oxygen levels in the water dropping to near zero. Acid rain on a scale that dissolved limestone. This is not the gradual poisoning you would expect from volcanism. This is a cascade, a runaway series of feedback loops that devastated the planet faster than life could possibly adapt. And while volcanism could have contributed, some researchers have quietly noted that the initial trigger, the thing that set off the cascade, is not clearly identified in the rock record. Then there are the iridium anomalies. Iridium is a rare element on Earth's surface but common in asteroids and in the deep mantle. When we find iridium spikes in rock layers, it usually means either an asteroid impact or massive volcanic eruptions, bringing deep mantle material to the surface. The Permian-Triassic boundary has iridium anomalies, but they are patchy, inconsistent, showing up in some locations but not others. That pattern does not match a single large impact, and it does not quite match the spreading pattern you would expect from the Siberian volcanism either. A few geologists, the ones willing to risk their reputations, have suggested that the iridium might indicate multiple smaller impacts or explosions, not natural asteroid strikes, but detonations. Events that would create localized iridium signatures if they involved materials from deep underground, or if they were energetic enough to vaporize rock and scatter heavy elements across the landscape. Could the Siberian traps themselves have been triggered by something artificial? Could weapons testing, or industrial accidents, or even deliberate warfare have destabilized the region geologically, cracking the crust and allowing massive magma flows to begin? There is no direct evidence for this, but there is also no complete natural explanation for why the Siberian traps erupted when they did, why they erupted so catastrophically, and why the extinction happened so much faster than volcanism alone should cause. What we are left with is a planet that was thriving, that had been thriving for tens of millions of years, and then suddenly, catastrophically, nearly died. The survivors were the small, the simple, the organisms that could hide underground or in deep water and wait for the world to stabilize. Everything complex, everything large, everything that required stable ecosystems was wiped out. And when life finally recovered 10 million years later, the world was reset. The dominant species were gone. New groups rose to take their place. It was as if someone had erased the hard drive and started over. Now jump forward in time, way forward, to just 12,800 years ago. In geological terms, this is yesterday. This is practically modern history. And yet, something happened at this moment that fundamentally changed the trajectory of human civilization. It is called the Younger Dryas Impact Event, and for decades, mainstream archaeology refused to even consider it. The evidence was dismissed, the researchers were mocked, and the idea that a cosmic impact could have reset human development was treated as pseudoscience, until the evidence became too overwhelming to ignore. Here is what we know. 12,800 years ago, Earth was coming out of the last ice age. Glaciers were retreating, the climate was warming, human populations were growing, and then, suddenly, everything reversed. Temperatures plummeted, glaciers advanced again. Megafauna, giant mammals that had survived the ice age, suddenly went extinct. Mammoths, mastodons, saber-toothed cats, giant ground sloths, all gone within a few centuries. In North America, an advanced culture called the Clovis people, known for their sophisticated stone tools and widespread trade networks, vanished. Their distinctive spear points disappear from the archaeological record almost overnight. Settlements were abandoned, populations collapsed, and a layer of sediment, found across North America and Europe, tells a story of fire and destruction on a continental scale. This layer, known as the Younger Dryas boundary layer, contains several things that should not be there if this were just a natural climate shift. Nanodiamonds, microscopic diamonds that only form under extreme pressure and temperature, like in asteroid impacts or nuclear explosions, magnetic spherules, tiny balls of melted rock that indicate temperatures hot enough to vaporize stone. iridium, again, suggesting extraterrestrial material. And perhaps most tellingly, a platinum spike, concentrations of platinum hundreds of times higher than normal background levels. Platinum does not just appear in sediments randomly. It is rare on Earth's surface, but common in asteroids and comets. The concentration found in the younger Dryas boundary layer suggests a massive influx of extraterrestrial material, not just a single impact, but possibly multiple airbursts or impacts across a wide area. For years, scientists argued that these markers could be explained by volcanism or wildfires or contamination. But in 2018, research teams using new dating techniques confirmed that the markers appear simultaneously across multiple continents at exactly 12,800 years ago. The same moment, the same catastrophe. The implications are staggering. If a comet or asteroid fragmented in Earth's atmosphere and detonated across North America and Europe, the destruction would have been biblical. Forests would have ignited, glacial ice would have melted catastrophically, causing massive flooding. The thermal pulse would have killed anything in the open, and the impact winter that followed, caused by debris blocking sunlight, would have plunged the world back into Ice Age conditions. But here is where it gets even more interesting. Some researchers, most notably Graham Hancock, have suggested that before this impact, there was a global maritime civilization, an advanced culture that had mapped the world, built sophisticated structures, and achieved a level of technological development that we are only now beginning to recognize. Göbekli Tepe, in Turkey, a site with massive carved stone pillars arranged in circles, is dated to 11,600 years ago, just 1,200 years after the Younger Dryas impact. It was built by people who, according to standard archaeology, should have been primitive hunter-gatherers with no organizational capacity or architectural knowledge. Yet the stones at Göbekli Tepe weigh up to 20 tons each. They are carved with intricate reliefs of animals and symbols. The site required planning, labor coordination, and skills that supposedly did not exist yet, unless those skills were not new, unless they were remnants, survivors of a culture that was nearly destroyed and was trying to rebuild. Hancock and others point to ancient maps, like the PRE-DINOSAUR map from 1513, which shows the coastline of Antarctica without ice. How did a medieval cartographer have access to accurate maps of a continent that would not be officially discovered for another 300 years? The standard explanation is that the map is based on older sources, ancient maps that have since been lost. But that just pushes the question back. Who made those ancient maps? And how did they survey Antarctica when it has been under ice for thousands of years? Unless it was not always under ice. Unless, before the Younger Dryas impact, the climate was different and Antarctica was accessible. And unless someone was there, mapping it, before the catastrophe hit. The establishment response to this line of thinking has been vicious. Hancock has been called a fraud, a charlatan, someone spreading dangerous misinformation. Archaeologists have written entire books attacking him. University departments have banned his work from being cited. But what they have not done is address the actual evidence. The platinum spike, the nanodiamonds, the sudden extinction of megafauna, the appearance of advanced structures immediately after the impact, the maps that should not exist. They dismiss it because accepting it would mean rewriting history. It would mean admitting that civilization is older than we thought, that advanced cultures existed and were destroyed, that the timeline we teach in schools is incomplete at best and fundamentally wrong at worst. Now, let us go back even further, to 445 million years ago, the Ordovician Silurian extinction event. This one killed 85% of all marine species. It happened in 2 pulses, separated by a few 100,000 years. The official cause is listed as glaciation and sea level changes. Ice sheets formed rapidly in the southern hemisphere, locking up water and lowering sea levels. Marine habitats were destroyed, oxygen levels dropped, and life collapsed. But the glaciation itself is poorly explained. The Ordovician was a warm period. CO2 levels were high. There was no obvious reason for a sudden ice age. Some geologists have proposed that volcanic activity released sulfur aerosols that cooled the planet, triggering the ice age. But the volcanic evidence is weak, and the timing does not match well. What is documented, however, is a sudden and dramatic drop in atmospheric carbon dioxide. CO2 levels fell by more than half in a geologically short period. Something pulled massive amounts of carbon out of the atmosphere. The standard explanation is increased weathering of rocks and burial of organic carbon in ocean sediments. But the scale and speed of the drawdown are extreme. Could an advanced civilization have attempted geoengineering? Could they have tried to cool the planet, perhaps in response to a warming crisis, and overcorrected, triggering a runaway ice age? We have no proof, but we also have no complete natural explanation. And the pattern, rapid environmental change, mass extinction, followed by a long recovery period, is the same pattern we see over and over in Earth's history. Extinctions reset the world. They erase complexity. They destroy the dominant species and give opportunities to whatever survives. And if civilizations existed during these periods, the extinctions would erase them too, not just killing the populations, but burying their traces under kilometers of ice, or sediment, or new rock formations. When we look at mass extinctions, we are told to see them as natural processes, random catastrophes that clear the board and allow evolution to try again. But what if they are not random? What if some of them, not all, but some, are the endgame of civilizations that pushed too far, changed their environment too much, or destroyed themselves through war or accident? The Earth has hosted life for billions of years. Intelligence has emerged at least once. Why would it only emerge once? And if it emerged more than once, why would we expect all of those intelligences to have avoided the same catastrophic mistakes we are currently flirting with? The rocks show us worlds that ended suddenly. The chemistry shows us disruptions that look industrial. The artifacts, when they are not hidden or dismissed, show us objects that should not exist. And the extinctions, these massive resets that punctuate Earth's history, might not just be erasing species, they might be erasing entire chapters of intelligence that we will never recover. Unless we are willing to look at the evidence without assuming we already know the answer. There are places on this planet where stone has been cut with a precision that should not be possible. Not with Bronze Age tools. Not with copper chisels and wooden mallets, not even with most modern equipment, unless you know exactly what you are doing. Yet these cuts exist, these structures stand, and the explanations we are given for how they were built become less convincing the more closely you examine them. Baalbek, Lebanon. In the foundation of the Roman temple complex, beneath layers of relatively recent construction, sit 3 stone blocks known as the trilithon. Each block weighs approximately 800 tons. 800 tons. That is roughly the weight of 3 Boeing 747 aircraft, carved from solid limestone, transported from a quarry a quarter-mile away, and lifted into place with such precision that you cannot slide a piece of paper between them. The Romans built on top of these stones, that much is clear. But even Roman engineers, with all their technological sophistication, their understanding of leverage and counterweights and construction techniques, never claimed to have placed the trilithon. Their own records describe the foundation as already ancient when they arrived. They built their temple on top of it because the platform was already there, perfectly level, immovably solid. In the quarry nearby sits another block, even larger, 1,200 tons, still partially attached to bedrock. It was being cut, shaped, prepared for transport, and then abandoned. Why? Why would ancient builders invest the enormous effort to carve a stone that size, and then just leave it? What happened that made them stop? Modern engineers have attempted to work out how you would move an 800-ton block with ancient technology. The calculations require thousands of workers, hundreds of rollers, precisely engineered ramps, and coordination that would challenge even contemporary construction companies. And that is just to move it. Lifting it into position, 20 feet off the ground, fitting it perfectly against 2 other blocks of the same impossible size. That requires technology we can barely replicate today, even with hydraulic cranes and computer modeling. The standard explanation is that we are underestimating ancient ingenuity, that given enough time, enough labor, and enough determination, people with simple tools can accomplish extraordinary things. And that is true, to a point. But Baalbek is not extraordinary in the sense of impressive. It is extraordinary in the sense of impossible, given the stated timeline and available technology. Now go to Pumapunku in Bolivia. Here we find something different. Not massive size, but insane precision. Andesite blocks carved with flat surfaces, accurate to within a few thousandths of an inch. Perfectly straight edges. Right angles so exact they could be used to calibrate modern machine tools. Interlocking shapes, complex geometric cuts, H-shaped grooves that look like they were designed for some kind of modular assembly system. Andesite is one of the hardest stones on Earth. It rates between 6 and 7 on the Mohs hardness scale. You cannot carve it with copper tools. Copper is too soft. It would deform and wear away before making any significant cut in andesite. Even iron tools would struggle. To achieve the level of precision found at Pumapunku, you need diamond-tipped saws, carbide drills, or laser-cutting equipment. Archaeologists tell us Pumapunku was built around 600 CE by the Tiwanaku culture. That dating is based on pottery and organic material found at the site. But the dating does not tell us when the stones were cut, only when people were living there. The precision blocks could be far older, with later cultures simply occupying and modifying a site they found already built. Some researchers have noted that many of the blocks at Pumapunku show signs of extreme heat exposure, vitrification, the process of stone melting and resolidifying into glass, on surfaces that should not have been exposed to temperatures high enough to cause that effect. What could generate heat intense enough to partially melt andesite? Conventional fires do not burn hot enough. Volcanic activity would destroy the precise cuts, not preserve them. But a thermal weapon, an explosion, something energetic enough to create a blast wave and extreme localized heat that could explain the damage patterns. It would also explain why the site looks less like a structure that gradually decayed and more like one that was violently destroyed, with massive blocks thrown around and scattered as if by an enormous force. Then there is Antarctica. Yes, Antarctica, the continent we think of as a frozen wasteland, uninhabitable, covered in ice miles thick. But it was not always frozen. We know from ice core data and geological evidence that Antarctica had periods of being ice-free. The question is, when and whether humans, or something else, were ever there. The Piri race map, drawn in 1513 by an Ottoman admiral, shows the coastline of Antarctica with remarkable accuracy. Not the ice, the actual coastline underneath the ice. Features that match modern seismic surveys of the bedrock beneath the ice sheet. The map is not perfect, but it is far too accurate to be coincidence or guesswork. Piri Reis himself wrote notes on the map indicating that he compiled it from older sources, some dating back to the time of Alexander the Great or earlier. That means the original surveys, the source maps showing ice-free Antarctica, had to have been made thousands of years ago at minimum. But according to standard geology, Antarctica has been glaciated for at least 34 million years. Except, not continuously. There is evidence of warmer periods, interglacial phases, when parts of the continent may have been accessible. If the Younger Dryas impact occurred 12,800 years ago, the climate disruption it caused could have temporarily exposed Antarctic coasts before the ice returned. Long enough for someone to map it. Long enough for that knowledge to be passed down through successive civilizations until it ended up in Ottoman archives. In 2001, satellite imaging and ground-penetrating radar surveys of Antarctica revealed geometric anomalies beneath the ice in several locations. Straight lines, right angles, structures that do not match known geological formations. The data was presented at a conference, published in a technical journal, and then quietly ignored. Funding for follow-up expeditions was denied. The researchers moved on to other projects. When Admiral Richard Byrd led Operation High Jump to Antarctica in 1947, the largest Antarctic expedition ever mounted with 13 ships and over 4,000 personnel, the official mission was to establish research bases and test equipment in polar conditions, but the expedition was cut short. Byrd returned months earlier than planned, and in interviews afterward, he made strange statements about the continent containing resources and mysteries that could change everything we know. His full reports were classified. Parts remain classified to this day. Why? What did they find that required military-level secrecy? What is under the Antarctic ice that we are not supposed to know about? Underwater sites present another problem. The Yonaguni Monument off the coast of Japan. Massive stone formations, some over 75 feet tall, with flat terraces, straight edges, and what appear to be carved steps and roads. Discovered by divers in 1987, the structure sits 100 feet below the surface. Geologists are split. Some say it is a natural formation, the result of erosion and tectonic activity, creating coincidentally regular shapes. Others, including marine geologist Masaaki Kimura, who has studied the site for decades, argue that the precision of the cuts, the presence of what look like tool marks, and the overall layout indicate artificial construction. If it is artificial, then it was built when sea levels were lower, before the area flooded. That puts construction at least 10,000 years ago, possibly much older. A massive megalithic structure built by a culture that supposedly did not exist yet. The Baltic Sea anomaly is another one. Discovered in 2011 by sonar imaging, it shows a circular object, 60 meters across, sitting on the ocean floor, with what appear to be straight lines, ramps, and geometric features. Initial reports described it as looking technological, almost like machinery. Dive expeditions found the object covered in sediment, but confirmed its unusual shape. Then the story changed. Experts began calling it a glacial formation. Media coverage stopped. The dive team, who had been planning extensive surveys and documentary filming, went silent. Attempts by independent researchers to organize follow-up dives were blocked by Swedish authorities citing environmental concerns. What is down there? Why does every attempt to study these underwater anomalies in detail get shut down or defunded? Why are certain areas of the ocean floor, certain coordinates, restricted by military or government agencies, with no public explanation? Precision stonework, impossible engineering, maps of places that should not have been accessible, structures underwater and under ice. Each one is dismissed individually. Natural formation, ancient ingenuity, coincidence, misidentification. But together, they point to the same unsettling conclusion. Someone built these things. Someone had the technology, the knowledge, the capability to work stone with machine precision, to survey continents, to construct on scales that challenge us even today, and that someone existed before our accepted timeline of civilization begins. The stones do not lie. The cuts are real. The maps exist. The structures stand, or sit beneath water and ice, waiting. And the questions remain unanswered, because answering them would require admitting that history as we teach it is incomplete. The evidence is carved in stone, literally, and stone lasts far longer than any institution's willingness to face uncomfortable truths. The pattern is always the same. An artifact is discovered. It gets documented. Photographs are taken. Witnesses come forward. The object is sent to an official institution for analysis, and then it vanishes. Not just physically disappears, though that happens too, but vanishes from the record. No published analysis, no follow-up research, no explanation, just silence. This has happened so many times, with so many different discoveries, that it stops looking like coincidence and starts looking like policy. The Smithsonian Institution holds the largest collection of artifacts in the United States. Over 155 million items spread across multiple facilities, most of which the public never sees. The museum displays maybe 1% of its collection. The rest sits in storage, catalogued and archived, theoretically available to researchers, but in practice nearly impossible to access unless you have the right credentials and connections. Former Smithsonian employees, speaking anonymously, have described a classification system that goes beyond the public catalogue. Certain items are flagged with codes that restrict access even to internal researchers. Request files on these items, and you get told they are being studied, or they are in conservation, or they have been moved to another facility. Ask which facility and the answers become vague. Push harder, and you might find yourself no longer welcome. In the early 1900s, newspapers across America reported discoveries of giant human skeletons, 7 feet tall, 8 feet. Some reports claimed 10 feet or more. These were not sensational tabloid stories. They appeared in reputable papers like the New York Times. They included statements from local officials, doctors, and scientists who examined the remains. Photographs were taken, though most of those photographs have since disappeared. Many of these skeletons were reportedly sent to the Smithsonian for study. The institution acknowledges receiving some remains, but claims they were normal-sized individuals whose measurements were exaggerated in the press. However, researchers who have gone through old Smithsonian correspondence logs found internal memos discussing the receipt of unusual specimens that needed to be kept from public view to avoid feeding popular misconceptions. In 1993, a researcher named Ivan T. Sanderson claimed to have spoken with multiple Smithsonian insiders who confirmed that giant skeletons and other anomalous artifacts were routinely filed under incorrect classifications, stored in restricted areas, or in some cases deliberately destroyed. When Sanderson went public with these allegations, the Smithsonian issued a blanket denial, but they did not open their archives for independent verification. They did not allow outside researchers to audit their collections. They just said it was not true and refused further comment. Why? If the claims are false, why not simply open the storage facilities to a neutral third party and settle the question? Why maintain such strict control over access? What exactly is being protected? Government and military involvement adds another layer. Certain archaeological sites are under permanent military jurisdiction with no clear explanation. In Egypt, The Giza Plateau has restricted zones that even credentialed archaeologists cannot access without special permission that is almost never granted. Ground-penetrating radar surveys have detected chambers and voids beneath the Sphinx and the pyramids, but proposals to investigate them are consistently denied by the Egyptian Ministry of Antiquities in coordination with other governments. When a team of researchers did manage to run unauthorized scans in the early 2000s, their equipment was confiscated, their data erased, and several team members were banned from ever working in Egypt again. What was in those scans? What did they find that required such an aggressive response? Antarctica, as we mentioned, has entire regions designated as restricted zones. The official reasons are environmental protection and preservation of pristine research areas. But the restrictions are enforced by military assets. Unauthorized flights over certain coordinates are intercepted. Ships attempting to approach specific coastal areas are turned away. Satellite imagery of some regions is deliberately degraded or delayed in public releases. Under the Antarctic Treaty, signed in 1959, the continent is supposed to be open for peaceful scientific research. Yet vast areas remain off-limits with no published justification. What is there that requires armed enforcement to keep people away? DARPA, the Defense Advanced Research Projects Agency, has funded multiple studies into ancient sites and anomalous artifacts. These projects are not publicized. They do not appear in civilian research databases, but budget documents, obtained through Freedom of Information requests, show funding allocated to projects with names like Historical Material Analysis and Deep Time Technology Assessment. The details are classified. The results are never published. Why would the United States military be interested in ancient history? Unless it is not just history. Unless some of these artifacts, some of these sites, contain technology or knowledge that has current strategic value. Academic gatekeeping operates more subtly but just as effectively. Peer review is supposed to ensure quality and accuracy in scientific publishing, but it also serves as a filter, a way to suppress ideas that challenge established paradigms. Researchers who submit papers on controversial topics, alternative dating of ancient sites, anomalous artifacts, pre-human civilizations, find their work rejected not because of flawed methodology, but because the conclusions are too extraordinary. This happened to Dr. Robert Schoch, a geologist from Boston University who studied the weathering patterns on the Sphinx. His analysis suggested the Sphinx was far older than Egyptologists claimed, possibly dating back 10,000 years or more, based on water erosion patterns. His geological evidence was solid. His methodology was sound, but Egyptologists attacked him viciously. They questioned his credentials, his integrity, his motives. They refused to engage with the evidence and instead worked to ensure his research was marginalized. Graham Hancock, who we have mentioned several times, has faced the same treatment. His books sell millions of copies. His documentaries reach massive audiences, but the academic establishment treats him as a pariah. Universities ban his work from being cited. Archaeologists write papers not to address his evidence, but to discredit him personally. He has been called a pseudoscientist, a fraud, a danger to public understanding of history. But when you actually read Hancock's work, when you look at the sources he cites and the evidence he presents, it becomes clear that the attacks are not about his accuracy. They are about control, about protecting a narrative, about ensuring that certain questions do not get asked and certain answers do not gain traction. Funding is the other weapon. Research into mainstream topics, studies that confirm existing models, gets funded readily. Grants are available. Institutions support it. But propose research into alternative timelines, into the possibility of pre-human civilizations, into anomalous artifacts, and the funding disappears. Universities distance themselves. Tenure committees suddenly find problems with your work. Scientists need funding to do research. They need institutional backing to access sites and equipment. And they need the approval of their peers to get published and maintain their careers. When all three of those things are controlled by people who have decided that certain ideas are unacceptable, the result is not science. It is orthodoxy. Real science welcomes challenges. It tests hypotheses against evidence. It follows the data wherever it leads. But what we have now, in archaeology, in geology, in paleontology, is a system that punishes deviation. That treats alternative theories not as opportunities for investigation but as threats to be eliminated. The artifacts vanish into storage. The sites get restricted. The researchers get discredited. The funding gets cut. And the narrative remains unchanged. We are the first. We are unique. Nothing came before us. And anyone who suggests otherwise is not a scientist. They are a conspiracy theorist. But when the conspiracy is real, when the suppression is documented, when the pattern repeats across decades and institutions, maybe being called a conspiracy theorist is not the insult they think it is. Maybe it is just an acknowledgement that you are asking questions someone desperately does not want answered. Mythology is usually dismissed as primitive storytelling, ancient people trying to explain natural phenomena they did not understand, inventing gods and monsters to make sense of thunder, earthquakes, the changing seasons. We treat these stories as fiction, as entertainment, as cultural artifacts with no basis in historical reality. But what if we have that backward? What if mythology is not fiction pretending to be truth, but truth that has been transformed into fiction through thousands of years of retelling? Every ancient culture on Earth has flood myths, not just one or two, but hundreds of distinct traditions from completely separate civilizations describing the same basic event: a catastrophic deluge that destroyed the world, waters rising to cover mountains, humanity nearly wiped out, only a few survivors remaining to rebuild. The Bible has Noah, the Epic of Gilgamesh from Mesopotamia has Utnapishtim, Greek mythology has Deucalion, Hindu texts describe Manu, the Aztecs have their flood story, the Maya have theirs. Australian Aboriginal traditions speak of a great flood. Native American tribes across both continents have independent flood narratives. These cultures had no contact with each other when these stories originated, yet the details align with disturbing consistency. Mainstream archaeology explains this as different cultures independently mythologizing local flooding events, or as stories spreading through ancient trade routes and getting adapted by each culture. But the specifics are too similar, the scale too consistent. Waters covering the entire world, mountains submerged, divine or cosmic forces involved, and most tellingly, the survivors are always described as preserving knowledge, saving the wisdom of the previous world to pass on to the next. What if these are not myths? What if they are fragmented memories of an actual global catastrophe? The Younger Dryas impact we discussed, transmitted orally through generations until they took on mythological characteristics, but retained the core truth. The world really did flood, civilization really was destroyed, and the survivors really did try to preserve what they could. Hindu cosmology takes this even further. The Vedic texts describe time as cyclical, moving through vast ages called yugas. 4 yugas make up one cycle, and each cycle lasts millions of years. The current age, the Kali Yuga, is described as a dark age of ignorance and decline. But it is preceded by the Dvapara Yuga, the Treta Yuga, and the Satya Yuga, each progressively longer and more advanced than the one that follows. In the Satya Yuga, humans supposedly lived for thousands of years and possessed abilities we would now call supernatural. They had flying vehicles called vimanas. They wielded weapons that sound remarkably like nuclear devices, creating blasts of light and heat that could level entire cities. The Mahabharata, one of the great Sanskrit epics, describes a weapon called the Brahmastra that produces a column of smoke and fire that reaches into the heavens, burns with the light of 10,000 suns, and leaves the land barren for years afterward. Read those descriptions and try not to think of nuclear weapons. Try not to picture mushroom clouds and radiation poisoning and nuclear winter. The text even describes survivors losing their hair and nails, their skin burning, their bodies wasting away, symptoms identical to acute radiation syndrome. Western scholars dismiss this as poetic exaggeration, as metaphorical language describing conventional warfare or natural disasters. But the descriptions are technical. They include details about the weapons being stored in containers, activated through specific rituals or mechanisms, and their use being restricted because of their devastating power. These do not read like flowery mythology. They read like operational manuals filtered through religious language. And the timescales, millions of years for each yuga, time enough for civilizations to rise, develop technology, destroy themselves, and be forgotten completely before the next cycle begins. Hindu cosmology does not treat humanity as a single linear story. It treats us as one iteration, in a pattern that repeats endlessly. We are not the first Kali Yuga. We will not be the last. Then there is Atlantis. Plato described it in 2 dialogues, Timaeus and Critias, written around 360 BCE. He presented it not as allegory but as history, claiming the story came from Egyptian priests who told it to the Athenian statesman Solon around 590 BCE. According to Plato, Atlantis was a powerful maritime civilization that existed 9,000 years before Solon's time. That places it around 11,600 years ago. Right around the Younger Dryas impact, Plato described Atlantis as technologically advanced, with sophisticated architecture, engineering, and naval capabilities. He said it controlled territories across a vast area before being destroyed in a single day and night of catastrophic earthquakes and floods, sinking beneath the ocean. For centuries, scholars have debated whether Atlantis was real or fictional. The common position is that Plato invented it as a philosophical device, but he goes into enormous detail about its geography, its political structure, its technology, details that serve no philosophical purpose, and he explicitly states multiple times that the story is true, handed down from reliable sources. What if Plato was reporting actual history, filtered through Egyptian records, describing a real civilization that was destroyed in the Younger Dryas catastrophe? What if Atlantis is not the name of one city, but a term for the entire pre-impact global culture? The maritime civilization that Graham Hancock and others argue mapped the world and built the megalithic structures we cannot explain. Lemuria, or Mu, appears in traditions across the Pacific. Polynesian, Indonesian, and South American legends describe a great landmass that once existed in the Pacific Ocean, inhabited by an advanced people, before sinking beneath the waves. While there is no geological evidence for a continent-sized landmass in the Pacific, sea levels were much lower during the Ice Age. Large islands and coastal areas that are now underwater were habitable. Could these legends be describing real places, real cultures, lost when the Ice Age ended and sea levels rose? The Sumerian texts present another problem. The Anunnaki, described as gods, who came from the sky, who created humans through genetic manipulation to serve as workers, who possessed advanced technology and knowledge. Zecharia Sitchin spent decades translating and interpreting these texts, arguing that the Anunnaki were not gods, but an advanced civilization, possibly extraterrestrial, possibly survivors of an earlier Earth civilization, who genetically engineered modern humans. Mainstream scholars reject Sitchin's translations and interpretations, but the Sumerian texts themselves are real. The descriptions of creation, of genetic manipulation, of beings with lifespans measured in thousands of years, of technology that allowed flight and communication across vast distances, all of this is in the original texts. What if the Anunnaki were not aliens from another planet, but survivors from an earlier cycle, from a pre-human or early human civilization that had developed advanced biotechnology? What if they did manipulate genetics, not creating humanity from scratch, but uplifting existing hominids, creating us as a hybrid species, combining their intelligence with the physical capabilities of our ancestors? Our DNA contains mysteries, junk DNA, sequences that serve no apparent function but make up the majority of our genome, genes that appear suddenly in the human lineage with no clear evolutionary path, a chromosome fusion that separates us from other primates, a fusion that looks less like natural mutation and more like intentional editing. I am not saying the ancient astronaut theory is definitely correct, but I am saying the mythology, when you strip away the religious interpretation and look at what is actually being described, points to the same conclusion as the geological evidence. The artifacts, the isotopic signatures. Someone was here before us. Someone with technology. Someone who left traces in our stories because the stories are all we had left after everything else was destroyed. Mythology is dismissed because it sounds impossible. But impossible only means it does not fit what we currently believe. And what we currently believe is based on an incomplete record, suppressed evidence, and an institutional refusal to ask uncomfortable questions. The myths agree with each other. They agree with the geological catastrophes. They agree with the timelines of the Silurian hypothesis. And they agree on one central point. We are not the first. We are not unique. And the cycle will continue long after we are gone. We have been going for a while now, digging through evidence that most people never hear about, connecting dots that institutions work very hard to keep separated. And I want to know, are you still here? Are you still following this? Drop a comment right now and tell me where you are watching from. What country? What city? I want to see how far this information is spreading. How many of you around the world are waking up to these possibilities? Comment your location. Let me know you are paying attention, because what comes next ties everything together in ways you might not be ready for. Something has been happening in the last few years that barely gets mentioned in mainstream news. Discovery after discovery, published in peer-reviewed journals, quietly dismantling the timeline we were taught. Not fringe theories posted on conspiracy websites. Actual scientific findings from credentialed researchers at major institutions, and every single one of them pushes the boundaries of what we thought we knew about intelligence, technology, and the deep history of life on Earth. In 2015, researchers working in Kenya found stone tools dated to 3.3 million years ago. That is 700,000 years older than the oldest known members of the genus Homo. Whoever made those tools was not human in any sense we recognize. They were pre-human. Australopithecines, maybe. Small-brained, ape-like creatures that, according to everything we were taught, should not have been capable of intentional tool manufacture. But the tools are sophisticated. Sharp flakes struck from larger stones using techniques that require planning and understanding of fracture mechanics. Not accidental, not random, deliberate. The researchers published their findings in Nature, one of the most prestigious scientific journals in existence, and the implications were staggering. If creatures with brains 1/3 the size of ours could make tools, then intelligence is not about brain size. It is about something else, something we do not fully understand. Then, in 2017, fossil footprints discovered in Crete were dated to 5.7 million years ago. Hominin footprints, upright walking, in Europe, nearly 6 million years ago. The problem is that all accepted models of human evolution say hominins only existed in Africa at that time. They did not leave Africa until around 2 million years ago. These footprints should not exist. The dating has been challenged, re-examined, and confirmed multiple times. The footprints are real. The timeline is wrong. 2019 brought another shock. Homo naledi, a strange hominin species discovered in South African caves in 2013, was found to have been deliberately burying its dead, creating graves, placing bodies in specific positions in hard-to-reach cave chambers. This is behavior we associate with symbolic thinking, with ritual, with culture. And Homo naledi had a brain the size of an orange, 350 cubic centimeters, compared to our 1400. Small-brained hominins were not supposed to bury their dead. They were not supposed to have symbolic behavior. They were supposed to be primitive, barely above animals in cognitive capability. But the evidence says otherwise. The graves are intentional. The placement is deliberate. Homo naledi was doing things that we thought only large-brained humans could do. And then there is the Denisovan problem. Denisovans are a mysterious hominin group, known mostly from DNA, extracted from a few fragments of bone and teeth found in Siberia. We have almost no physical fossils, but we have their genome. And that genome tells a strange story. Denisovans interbred with modern humans. We carry their DNA, especially populations in Southeast Asia and Oceania. But the Denisovan genome also shows admixture from another, unknown hominin group. Something that is not Homo sapiens, not Neanderthal, not Denisovan. Something we have not identified yet. That unknown group contributed DNA that is still present in living humans today. We are walking around with genetic material from a hominin species that science has not even discovered. A ghost population that left no fossils, no artifacts, only fragments of its genome hidden in ours. Who were they? When did they live? And what happened to them? Every new genetic study reveals more complexity, more interbreeding, more ghost populations. The neat tree of human evolution, with each species in its own branch, is collapsing. What we are finding instead is a web, a tangled network of populations mixing and separating and mixing again over millions of years. And the further back we sequence, the stranger it gets. Climate records are revealing problems too. Ice core data from Antarctica and Greenland goes back nearly 1 million years, showing atmospheric composition with incredible precision. And there are anomalies. Carbon dioxide spikes that happen too fast to be explained by known geological processes. Methane pulses that do not correlate with temperature changes in the expected way. Isotopic ratios that shift suddenly and then revert just as suddenly. In 2022, a team analyzing deep ice cores found a layer dated to 350,000 years ago, with atmospheric chemistry that looked industrial. Elevated CO2, unusual nitrogen compounds, trace elements that suggested burning on a massive scale. The initial interpretation was wildfires, but the geographic distribution was wrong. The chemicals appeared globally, simultaneously, in concentrations that would require fires burning across entire continents at once. The paper was published, noted as an unexplained anomaly, and filed away. No follow-up funding was allocated. The researchers moved on. But the data is there, sitting in archives, waiting for someone to take another look with fresh questions. Then there is the work being done in astrobiology, the search for life beyond Earth. Researchers are developing methods to detect technosignatures, signs of technological civilizations on distant planets. They are asking what chemical markers, what atmospheric changes, what physical structures would indicate intelligence from light years away. And in doing so, they are creating tools that could just as easily be applied to Earth's own deep past. A paper published in 2023 proposed using spectroscopic analysis of ancient rock layers to search for industrial pollutants. The authors suggested that if an advanced civilization had existed millions of years ago, we might detect traces of synthetic compounds, heavy metal concentrations, or isotopic anomalies that natural processes could not produce. They outlined a methodology, identified potential target formations, and called for funding to begin systematic surveys. The response from the broader scientific community was muted. A few researchers expressed interest. Most ignored it. Funding agencies declined to support the work, citing more pressing research priorities. But the methodology is sound. The tools exist. We could be searching Earth's geological record for technosignatures right now if anyone was willing to fund it. NASA's Goddard Institute, the same institution where Gavin Schmidt works, has quietly continued research related to the Silurian hypothesis. Not actively searching for ancient civilizations, but refining the models of what we could and could not detect. Their latest work, published in late 2023, concluded that after approximately 50 million years, almost all traces of an industrial civilization would be undetectable using current methods. Physical artifacts would be gone. Chemical signatures would be ambiguous at best. Only the most extreme events, things like the Oklo-uranium depletion, might survive long enough to be noticed. 50 million years. That is 1/10 of the time since the Permian extinction. 1/20th of the time since the Carboniferous. If civilizations rose and fell in any of those periods, we would never see them. The evidence would be gone. But here is what is changing. 20 years ago, suggesting that non-human intelligence could develop tool use was career suicide. Now, it is published in Nature. 10 years ago, claiming hominins buried their dead before developing large brains would get you laughed out of conferences. Now it is accepted science. 5 years ago, proposing that we search Earth's geological record for ancient technosignatures would be dismissed as pseudoscience. Now NASA researchers are publishing methodologies for doing exactly that. The window is shifting. Slowly, reluctantly, but it is shifting. Questions that were forbidden are becoming acceptable. Evidence that was ignored is being reconsidered. And every new discovery, every anomaly that does not fit the standard model, pushes that window a little further open. We are not at the point where mainstream science is willing to say yes, ancient civilizations definitely existed, but we are reaching the point where they can no longer say with absolute certainty that they did not. The geological record is too incomplete. The evidence is too ambiguous. The timeline is too vast. And the discoveries keep coming, each one chipping away at the certainty that we are first, that we are unique, that intelligence only happened once. The data is accumulating, the tools are improving, and the questions are being asked, even if quietly, even if carefully, by people who know that the answers might change everything we think we know about where we came from and what might have been here before us. Science moves slowly. It resists paradigm shifts, but it cannot resist evidence forever. And the evidence, piece by piece, discovery by discovery, is building a case that the history of intelligence on Earth is far longer, far stranger, and far more complex than we have ever been willing to admit. If even 1% of what we have discussed is true, if even a single ancient civilization existed and vanished, the implications ripple outward in ways that fundamentally change everything. Not just our understanding of history, but our understanding of ourselves, our future, and our place in the cosmos. Start with the most basic question. Where did we actually come from? The standard narrative is that we evolved naturally from ape-like ancestors over millions of years through random mutation and natural selection. Slow, gradual, unguided. But our genome tells a stranger story. We have genetic sequences that appear suddenly with no clear evolutionary precursor. We have a chromosome fusion, chromosome 2, where two separate ape chromosomes merged into one. That fusion is unique to humans. It does not appear in any other primate. And it looks less like a random accident and more like an intentional edit. There are sections of so-called junk DNA, non-coding sequences that make up over 90% of our genome that serve no apparent function. But recent studies have found that some of these sequences activate under specific environmental conditions or developmental stages in ways we do not understand. What if they are not junk? What if they are dormant code, fragments of genetic engineering from a time we have forgotten? The ancient Sumerian texts describe the Anunnaki creating humans by mixing their essence with that of primitive hominids. Mythology calls it divine creation, but strip away the religious language and you are left with a description of genetic manipulation, taking an existing species and modifying it to create something new. We do this now with CRISPR and gene editing. We create transgenic organisms, hybrids, designer traits. What if someone did that to us? Not aliens from another planet necessarily, but survivors from an earlier cycle, a previous civilization that had mastered biotechnology, that needed workers or companions, or simply wanted to create something in their image before they disappeared. We could be their legacy, their final experiment, and the myths, the stories of gods creating humanity, could be fragmented memories of that engineering passed down through cultures that no longer understood the science behind it. This changes everything about how we see ourselves. We are not the product of blind chance. We are not the inevitable result of evolution. We are a designed species, created with intention, carrying genetic instructions we do not fully understand, possibly programmed with capabilities we have not yet activated. Then there is the warning. Every civilization that came before us, if they existed, is gone, erased so completely that we can barely detect their traces. That means survival is not guaranteed. Intelligence does not protect you from extinction. Technology does not save you. In fact, the more advanced you become, the more capable you are of destroying yourself. We are currently facing climate change, environmental collapse, resource depletion, nuclear proliferation, and artificial intelligence development that could spiral beyond our control. Every single one of these is a potential extinction-level threat, and if civilizations before us faced similar challenges, failed to overcome them, and vanished, then we are on the same path. We are repeating the cycle. The geological record shows us worlds that ended suddenly, carbon spikes that look like industrial collapse, extinction events that reset everything. If those were not purely natural disasters, if some of them were civilizations destroying themselves, then we are looking at our own future, not a possibility, a pattern, a cycle that repeats because intelligence, when it reaches a certain level, becomes inherently self-destructive, unless we learn, unless we recognize the pattern and choose differently. That is the value of knowing this history, even if incomplete, even if speculative. It shows us that failure is not just possible but probable, that the default outcome of technological civilization might be extinction, and that our window for changing that outcome is closing. There is also the cosmic perspective. If intelligence can arise more than once on Earth, then the universe is almost certainly full of it. The Drake equation, which estimates the number of communicating civilizations in our galaxy, has always included a variable for how long civilizations survive. Most optimistic estimates assumed thousands or millions of years. But if the pattern on Earth is rise, peak, collapse, and erasure within a few million years, then the galaxy could be filled with ruins, dead worlds, silent civilizations that came and went, leaving nothing but faint chemical signatures and unanswered radio silence. We search the stars for signs of life, but maybe we should be searching our own planet first. Maybe the answer to where everyone is, the Fermi paradox, is that they all followed the same path we are on. They developed technology, exploited their resources, changed their climates, and either destroyed themselves or collapsed so completely that their successor species, if any evolved, never knew they existed. That makes our moment in time incredibly precious. We are at the peak right now. We have global communication, space travel, nuclear power, genetic engineering, artificial intelligence. We are more powerful than any previous generation of humans. But power without wisdom is just a faster route to extinction. And wisdom means recognizing that we are not special, not exempt, not guaranteed to survive just because we are clever. The implications are uncomfortable. They challenge human exceptionalism. They suggest we might be repeating a pattern rather than blazing a new trail. They force us to confront the possibility that intelligence is common but survival is rare, that the universe is not empty, just full of ghosts. But discomfort is not a reason to ignore truth. The evidence exists, the questions are valid, and the answers, whatever they turn out to be, matter more than our comfort ever could. We have covered a lot of ground. Ancient nuclear reactors that should not exist. Metal spheres carved with precision 2 billion years ago. Artifacts embedded in coal 300 million years old. Chemical signatures in rocks that echo industrial activity. Mass extinctions that reset entire worlds. Structures built with technology we can barely replicate today. Suppression of evidence by institutions that claim to seek truth. Mythologies that describe cycles of rise and fall spanning millions of years. And modern scientific discoveries that keep pushing intelligence further back, making it older, stranger, more widespread than we ever imagined. Each piece of evidence, taken alone, can be explained away. Natural formation, coincidence, misidentification, hoax. The explanations are always ready, always convenient, always designed to preserve the narrative that we are first, we are unique, we are special. But when you step back and look at all of it together, when you see the patterns repeating across time and geography and disciplines, the explanations start to sound less like science and more like denial. The truth is, we do not know. We cannot know with certainty whether civilizations existed before us. The geological record is too incomplete. Time has erased too much. And the institutions that control access to evidence and funding for research have made it clear that certain questions are not welcome. But not knowing is not the same as knowing it did not happen. Absence of evidence, especially when that evidence would have been destroyed by natural processes over millions of years, is not evidence of absence. What we can say with certainty is this: Earth is unimaginably old. Life has existed for billions of years. Intelligence is an evolutionary strategy that has appeared at least once and possibly multiple times in different forms. The conditions for technological development have existed in multiple periods throughout deep time, and every trace we are leaving behind, every marker of our industrial civilization, will be virtually undetectable after just a few million years. If we vanished tomorrow, if some catastrophe wiped out humanity and gave the planet 10 million years to recover, what would remain? A thin layer of weird isotopes in sedimentary rock, some plastic particles compressed into future stone, maybe a few anomalous metal concentrations. That is it. No cities, no monuments, no clear evidence that we ever built anything or thought anything or mattered at all. Future geologists might find our layer and debate whether it represents a natural event or something stranger. And most of them would probably conclude it was natural because the alternative would require rewriting everything they thought they knew. That is where we are now, looking at layers that do not quite make sense, finding objects that should not exist, seeing patterns that natural processes do not fully explain, and being told by authorities that we are misinterpreting, that we are seeing what we want to see, that the simple explanations are always correct even when they do not actually fit the data. But some of us are not satisfied with simple explanations. Some of us see the gaps, the inconsistencies, the suppressed evidence and institutional gatekeeping, and we ask why. Why is access restricted? Why do artifacts disappear? Why are researchers who ask uncomfortable questions attacked and discredited? Why does the narrative matter more than the evidence? The answer is that paradigms are powerful. They shape how we see the world, how we interpret data, how we understand our place in history. And when a paradigm is threatened, when evidence emerges that does not fit, institutions do not objectively re-evaluate. They defend, they attack, they suppress. Because admitting the paradigm is wrong means admitting that careers were built on false assumptions, that textbooks need to be rewritten, that authority has been misplaced. So the evidence gets filed away, the questions get dismissed, and the story remains unchanged. We are the first. We are unique. Nothing came before us. And if you suggest otherwise, you are not a scientist, you are a threat. But truth does not care about paradigms. Truth does not care about careers or institutions or comfortable narratives. Truth just is. And the truth of Earth's deep history is vast, complex, and largely unknown. We are looking at fragments through a keyhole and calling it complete knowledge. We are examining 1% of the geological record and declaring we understand the other 99%. We are finding anomalies and explaining them away instead of investigating them honestly. What if Earth's first civilization was not human? What if intelligence arose before us, built something, achieved something, and then vanished into deep time, leaving only whispers in the rocks? We cannot prove it, but we also cannot disprove it. And the possibility, the mere possibility, should be enough to warrant serious investigation. Not mockery, not suppression, investigation. Because if we are not the first, then we need to understand why the others failed. We need to learn from their mistakes. We need to recognize the patterns of collapse and avoid them. And if we are the first, if this really is the only time intelligence has developed technology and culture, then we need to understand how rare and precious that makes us, how fragile our moment is, how easily it could all disappear. Either way, the question matters, the evidence matters, and the truth, whatever it turns out to be, matters more than our assumptions ever could. So keep asking questions, keep looking at the evidence, keep thinking critically, and do not let anyone tell you that curiosity is dangerous or that some questions should not be asked. Subscribe if you have not already. Share this with people who are ready to think differently. Comment your thoughts, your theories, your own experiences with evidence that does not fit the official story, because this conversation is just beginning. And the deeper we dig, the stranger it gets.